We have explored creating pointers to class objects and data primitives. In C++, we can also create pointers to functions. Today we're going to take a look at creating function pointers, or pointers to functions. And in the past, we've been examining pointers a lot, using pointers for indirection to indirectly access objects, using pointers with arrays and looping and repetition structures, using pointers to build things on the heap, using pointers to search and sort objects efficiently. But those are all pointers to either data primitives like integers and doubles and characters, or built-in classes of object like string and cstring, or more sophisticated classes of object programmer-defined classes like classes we would write ourselves. So what we're going to look at now is pointers to functions. We can do the same thing with functions that we've done with objects. And again, I put ourselves in the standard namespace here, so we don't have to worry about scoping into any of the standard objects. We've got a simple class hierarchy starting with a very small simple ADT, and our abstract data type just has a constructor and destructor and protected data member. And remember, our access modifiers are public, protected, and private. All right, going from the least, restricted to the most restricted. C++ virtual methods. Virtual methods are methods declared and defined in a parent-based superclass that are again defined in each child-derived subclass. They are overridden methods so that they have the same name in both the child and parent objects. Declaring a method as virtual in the base class means the derived class will always implement its own overridden method instead of its parents. There are also pure virtual methods. A pure virtual method is one that is required to be implemented in each derived class within the inheritance hierarchy. This enables one to enforce structure and order within the hierarchy. Pure virtual methods defined in the base class are never called and are usually defined in ADTs or abstract data types that are never intended to be instantiated by themselves. Pure virtual methods serve to organize code by forcing child objects to implement each inherited virtual method by overriding it in their own way as it is appropriate for them. Pure virtual methods are always initialized to 0 when declared in the base class. For example, virtual void sum func constant equals 0 is a pure virtual method. C++'s pure virtual methods can be compared to abstract methods in Java. Now, these methods are virtual, and by virtual, when we create a virtual method in a parent class object, that means that we are setting it up so that we have to override that method in any inherited or derived class objects. So all the child classes need the same virtual methods that are in our base class, speak and move. And if you're a Java programmer, or you've done a lot with Java, you can almost relate the keyword virtual to the keyword abstract in Java. Same thing. So, and not only are these methods virtual, but they're pure virtual, meaning that we can never use them. They're just initialized to be 0. So, they're virtual because of the keyword virtual, but they're pure virtual because they're initialized to 0. So, this is an abstract data type, and normally we don't build instances of an ADT. We just use it as scaffolding or framework for child classes and objects that inherit from it. Well, this is a way of enforcing structure throughout our class inheritance hierarchy. So these methods themselves would never be called on lifeform, but by making them pure and virtual, by using the keyword virtual and initializing them to 0, we're setting it up so that we have to implement these methods on all of our derived class objects. So it becomes sort of a skeleton or a scaffolding or a framework, and it gives our inheritance hierarchy some integrity and some structure to it. Okay, but when, really we're more interested in a more specific kind of a life form, be it a Cylon, be it a human, that inherits from it. So understanding what virtual is, understanding what a pure virtual method is. When a virtual method has been initialized to 0, we say it's pure virtual. And understanding that we're overriding. Therefore, all of our child classes need to have the methods with the same function name, but they do something different. When a Cylon speaks, it says I'm number 6. When a Cylon moves, it says resurrecting. When a human speaks, it says, hi, I'm a human, and when a human moves, it says, I'm reproducing, not resurrecting. So just our class inheritance hierarchy. We'll be using this later when we look at creating function pointers and arrays of function pointers that manipulate and use objects. But to start out with, we're going to start out with some simple function pointers. Let's examine some simple function pointers. So to create and manipulate these first few function pointers, we're going to have some globals, so 2 numbers here, and we're going to have a constant integer array size to build arrays with, and that way our arrays will all be the same size. And we're going to have a very simple string here, an array of type character. That'll hold 10 characters, and we'll use this just for input and a little bit of bulletproofing in our menus when we take input from the console. Let's look at our function prototypes. We have functions to square, cube, and swap, and change values on integers. These all take references to integers, okay? Then we have another function prototype here that will take two references to string objects, and another function that simply takes two plain old integers by value rather than by reference. We have all of these void functions here, and each one of these I've split into a different example that we'll take a look at. And then we have this function here that we'll use with a couple of the examples. And in this example, we're creating a function that accepts as an argument a pointer to a function, and in addition to accepting that pointer to a function, it also accepts two references. Okay. Down here we have our function pointers. So this first one is how we would set up or declare a pointer to a function that would point to, it would accept two references to integers as an argument. Now, just like any other pointer, we can reassign this to point to any function, provided that, or as long as it accepts or has the required data type in the arguments. Just as if we created a pointer to an integer, or a pointer to a rainbow unicorn, or a pointer to a dragon, or a pointer to a string, we could not make that pointer then turn around and point to something of a different data type. Well, in the same way, when we create a function pointer and we declare it, and we set up the arguments or the parameters, the only functions that that function pointer can point to are functions that match the parameter list, okay, the arguments. So any function that takes two references to integers, a function pointer 1 can point to. But it could not point to any function that had strings or dragons or anything else, any other kind of object. Likewise, a function pointer 2, that could be made to point to any function that accepts two references to strings as its arguments. But on the other hand, it could not be made to point to a function that accepted integers or doubles or some other data type. Okay, so we'll look at these examples of function pointer 1 and function pointer 2. And then here we have a function pointer array. This is just going to hold or be an array of function pointers. And we'll take a look at how to manipulate and deal with that. Let's gather a brief overview of the functions we will be pointing to. So let's follow through with our first example. I'm going to uncomment it in main so we can invoke and call the function. And then let's go down and look at the function definition. And also, before we do that, this function is going to take a function pointer and assign it to different functions. So let's take a quick peek at all the functions that we're going to be assigning that pointer to. So you have that kind of in the back of your brain, and you understand the background of what's going on. Well, when we call display vals, we're passing by value. It doesn't take references, just two plain old integers, and it's just going to display what we pass into it, x and y. Its only purpose is to simply display those values, okay? When we call two strings, now it accepts two strings by reference, and it's simply going to display those strings, string 1 and string 2. When we call square, now this takes arguments by reference. So rather than creating a copy and pass them by value, it's going to pass the address of the original object and therefore modify the original object. And it does what it says it does. It squares x and y. Cube, same thing. It cubes x and y, and it's by reference. So again, it modifies the original object by passing the memory address, does not create a copy, does not pass by value. Swap, again, by reference, using references or aliases. So the memory address is going to modify the original object. It's not a copy, it's not passing by value. And then changing the values. If we decide to change the values, also we're using references or aliases. So passing by reference with a memory address, we're going to modify the original object. We're not creating a copy. We're not passing by value. Okay, so these are all the functions that we're going to be having our function pointers point to. So now that you know what they are and what they do, let's take a look at the code for example 1, the very first function that we'll run. For example 1, we have a function pointer that accepts integers. Here we're just going to create a plain and simple function pointer. So we have our globals, remember num1 and num2? Well, we're initializing them to be 5 and 10 and setting our simple string, our character array, our array of type character, to be a space. And I'm just going to initialize a function pointer 1 to point to change values. Remember that was the function up here? And notice that when you assign a function pointer to point to a function, you don't include the parentheses like you normally would if you were invoking or calling the method or prototyping or defining the method. And there's some comment tags in here. The only reason I'm doing this, I don't have to do this. I could leave that whole section out if I wanted to. Just comment it out. But if I did that and I hit enter, then that would end up being a null pointer. Right? We'd have a null value, and that would crash our program. So anyway, we're initializing it to point to something. It's better than pointing to nothing. But ultimately, what we want to do is, when we run our menu, we want to go through and change the pointer to point to 4 different functions here: change value, square, cube, and swap. So this is just a standard old console menu in a while true loop, like you would any other console menu in a while true loop. Here's our simple string, our array of type character, and as long as it's not 0, and the reason we're doing this instead of using a number, if we could have made choice an integer, and we could have just done 0, 1, 2, 3, 4 as integers, but if they typed in B, A, C, D, we'd crash the program. It wouldn't be able to handle non-numerical input. And so there's ways you could handle that. You could try and catch and if and else, and you could use methods like isDigit and so forth. But an easy way to handle that is rather than taking it as, even if you want to use numbers, rather than accepting numerical values as an integer, accept it as a string. In this case, a single character of a string. In case I type in banana or something and it's more than one character, we don't want it to overflow the buffer and cause unnecessary looping or crashing or anything. All right, so we're using a whole string, but we're only looking at one single character, and we can use numbers, but we're not doing math with this. It's just from a menu. So it helps us bulletproof it a little bit by making it a character instead of an integer, because then we don't have to worry about them typing some weird thing in, banana pancakes or whatever that could crash the program. It's up to you how you choose to do it. So there's our menu. Anyway, the meat and potatoes, once we've displayed the options, the choices, and the user chooses what to do and we get input, is right here, the switch statement. Here's where we actually take our function pointer and we make it point to these different functions. And we can do this because these functions match the declaration of our pointer. And let's review that. If I jump up here, again, a function pointer 1, let me go right here, it can point to any function that takes, as its parameter list 2 arguments, 2 references to integers, okay? Now, if it's strings or the incorrect number of parameters or the incorrect data type, then a function pointer 1 could not be made to point to it. But if you look at all of our functions, they match that description, all the ones that we're implementing or that we're using. In this case, 2 references to integers for square, 2 references to integers for cube, 2 references to integers for swap, and 2 references to integers for change values. So therefore, we can use a function pointer 1 to point to all those functions. And we'll simply choose them one by one in the menu. When we do this and we take the input, we're just going to skip this part here if they choose to quit. We don't want to make them look at this if they choose to quit and go through it. But if they don't choose to quit and it's 1, 2, 3, or 4, then we're going to go ahead and call this, and we'll call display vals a function pointer 1, and we'll specify before and after, and then display vals after we call what the function pointer points to. So by reassigning the pointer, we're going to be able to call these 4 different methods using the same pointer and the same arguments being passed in, because they're all coded with a matching parameter list, okay, or a matching collection of arguments that fits the pointer, the way the pointer's been declared. So let's build it and run it, and this time we're going through example 1. And when we do this, let me modify the background here real quick. Okay. And so the first one will change the values. So before x is 5, y is 10, that's what they were set to. Let's set it to 3 and 9, all right, for num1 and num2. So x was 5 and y was 10. Now x is 3 and y is 9. That was function 1. Now let's change the pointer to point to a different function. This time we'll make it point to the square function. Okay, and so here it just squared those objects. Okay, and now let's take those values that it currently is and we'll make it point to the cube function. Alright, so we'll do that this time. And now pointing to the cube function, here are those values. And now let's once again change the pointer to point to the 4th method, swap. And whereas x was 729 and y was 531,441, now they've been swapped. X is now 531,441 and y is now 729. Okay, so just sort of our first example using a function pointer that can point to any function that takes two references to integers as its arguments. For example 2, we have a function pointer that accepts strings. Now let's uncomment, we'll comment out example 1 and uncomment example 2. Take a look at our next function and next example. So in example 2, we're going to use a function pointer 2, and it has been made to point to the method or function toStrings. Now we couldn't make it point to any of these methods because these all take two references to integers, as their arguments or parameters. However, we can make it point to this function up here, toStrings. toStrings takes two references to string objects. And remember that if you look at a function pointer 2, it takes two references to string objects. So what the pointer points to has to match in terms of the number and the data type of the arguments passed in. So again, if we look at example 2, we can do this because the method or the function toStrings accepts two references to strings, and a function pointer 2 has been declared to accept two references to strings as an argument. So we'll set it up to point to the method toStrings, and we're going to build two strings here. We'll call them 1 and 2. We'll say the quick brown fox is the value of 1, jumped over the blue moon is the value of 2. And then we're going to use our function pointer that points to the method toStrings and pass in 1 and 2. And when we do, remember that all that does up here is simply display. Let me go up here. All it does is simply display the strings on each line, string 1 and string 2, that come in by reference as x and y. So if we run it, rebuild the project and run it, let's take a look at how that works. The quick brown fox jumped over the blue moon. For example 3, we have an array of function pointers. Now let's take a look at example 3. And in example 3, we're going to create a function pointer array, okay? And when we do this, in our function pointer array, we're just going to take each function pointer as an element in the array and make it point to a different function. And we're going to put this on autopilot. Instead of making it menu choices we have to choose manually, we're going to put it inside of a for loop and automatically iterate through all four functions as we reassign the pointers, or have the pointers that point to these methods. And we'll just use our subscript value of x to go through the array. But looking at that, how would we manipulate that, a function pointer array? Let's go up here and take a look at how that looks, or how that works. Here's a function pointer array. And again, notice, just like a function pointer here, where it's a pointer to the pointer name, that'll be point to a function, and then the parameter argument list. Here it's the array name and the size of the array. In this case, it's a constant value, 4 elements, 4 methods, 4 functions we're going to make it point to. And again, we have to supply the parameter list, the arguments. And the data type and the number of arguments are important for what the kinds of function pointers that our array of function pointers can hold. So we're going to comment out example 2 and uncomment example 3, and now we will run it. And when we do, let me go down to example 3 here. Again, it's just going to be on autopilot, and each one of these pointers here in our array is going to be made to point to one of these methods. And then as that subscript value is called forth as 0, 1, 2, 3, the index value 0, 1, 2, 3, then we're going to call that method. Okay, so, and we're just matching the case here on these values, but I just copied and pasted this, and actually I didn't even really need that based on the case value. I could just use case 0, 1, 2, 3, but it doesn't matter. It's going to call, it's going to be assigned to point to this function or this method automatically, so it'll cycle through change value, square, cube, and swap, and we'll get to see how it works. And we're just going to call display values before. Then we're going to take our function pointer and perform the function, or call the method that it points to, 0, 1, 2, 3, all 4. And then we're going to display the values after we do that. And we're going to pause and clear the screen in between, just to, so we can see things a little bit better. So let's go ahead and run example 3. We'll rebuild the project. And I'll pull this down a little bit. All right, so again, with x having an initial value of 5 and y an initial value of 10, let's say that we change it, and again, we'll use the values 3 and 9. So now x are 3 and 9. All right, that was the first function. And if you look, go down here and pull this up, that was change values that the pointer was pointing to that got called. The next function or method is going to be square that it points to as our for loop is iterating, okay? So I'm going to hit spacebar. Calling function connected to pointer 1, okay? So that's pointer 0, this is pointer 1, the second method, which is square. In this case, we've done that. Our 3 and our 9 have been squared. All right, hit enter. Now pointer 2, 0, 1, 2, the third pointer, but remember it's off by 1. Start at 0, not start at 1. So pointer 2, which is our third pointer, and we're going to cube it. So 729, 531,441. And then finally, our last pointer, 0, 1, 2, 3, indexed as 3, but it's our fourth pointer. It's going to call the swap function. And so whereas x started out at 729 and y 531,441, now x is 531,441 and y is 729. In example 4, we'll review passing a function pointer to another function. Now, let's take a look at example 4. I'm going to come up here and we'll comment out 3, and we're going to uncomment example 4 this time. Let's go down and look at the code for example 4. Come down here, oops, not too far there. Example 4. Alright, so whereas before we had a function pointer array, in example 4, we're going to pass a function pointer to another function. And we're going to do the same thing here. We're going to take a function pointer 1, and it's going to point to a different method, and inside of a for loop, this is going to be on autopilot. It's just going to automatically cycle through each of these 4 functions or methods as the pointer matches the case, or as the case matches the subscript value of x, excuse me, then we'll make the pointer point to that method. And here we have a function, display vals with pointer function, and it takes 3 arguments. The first argument is a function pointer, and the last 2 arguments are numbers, number objects. And here's how it looks. Here's the the definition of the function. So it's just a function pointer, just like we defined before. There's the definition. And then by reference, it's going to take 2 integers. So we can call it this way. Remember, we don't have to use the addressive operator, the ampersand, when we pass by reference, even though the effect is the same as if you used a pointer without the dereferencing. So we have that, and then if we look up here, here's how it's prototyped. In this case, again, it's a function pointer prototype, and then 2 references to integers. Testing 1, 2, 3. So I'm going to scroll back down so you can kind of examine the code while we run it. And here's our example 4. And inside of our for loop, as we cycle through each method and reassign the pointer, we're going to be passing that pointer to this function here that takes 3 arguments, a function pointer and 2 numbers. It's going to do the same thing, but we're just looking at a different way to utilize and access and manipulate objects through a function pointer. Okay, and let's see, oops. That should be, well, it is example 4, but I forgot to change that. Let me change that so it's not, hopefully not confusing. Okay, so there's example 4 that we're in, and let's run through it. And our for loop will be on autopilot as we iterate through and reassign our pointer 4 times. Example 4, loop iteration number 1. X starts out as 5, y is 10. Again, I'll just use the values 3 and 9. And now after, x has a value of 3, y has a value of 9. I'm going to hit the next key, iteration 2, and we're calling the method square. Alright, as we call this method here, you cycle through, change values was the first method, next method is square, the next one will be cube, and the next one swap. And we're just passing it to this function, right, as a parameter, as an argument. So again, we'll cycle through the next 2. That was square, this is cube, and this is swap. In example 5, we'll look at pointers to class member methods. Now let's take a look at the next example, and just going to head on up to main, and let's comment out example 4, and we'll uncomment example 5. Take a look at the code. Alright, so 3, 4, and example 5 here. Here we're going to create a pointer to a class member function. And this is kind of weird looking until you get used to it. But basically, we need to watch the scope and precedence with our parentheses. So it's a parenthetical expression. And we need to resolve the scope. So we have the 2 colons, to resolve. In this case, we're scoping into the ADT, or the base class. So this pointer, life form member function pointer, I know that's a long name, but I'm trying to make the name, I'm trying to make the code as easy to follow as possible. So that way we don't need comment tags. The name of the object says what it is, what it's for, what it does, what its purpose is. So this is just a pointer to a life form member function, right? We have to resolve into it. We need the asterisk to declare it, set it up as a pointer. Okay, its return type is void, and we're initializing it, and it's set up to be constant. Okay, so this function here we can now use to point to a life form, function or method. But remember that if we look at our class hierarchy, let's go up here and remember these were virtual and they were pure virtual. So we could never really call speak and move from the ADT life-form. We can only call speak and move from Cylon and human. So if we take a look at that, in example 5, we're building a new Cylon object over here. So number 6 is a pointer, and it builds a new Cylon on the heap, and through number 6, the pointer, we can now access our new Cylon on the heap. We're going to take our pointer that was set up here to a lifeform member function, but it's pure virtual, so really it's a derived child class, Cylon or human, class member function pointer. And we're going to have it point to the address of lifeform speak. Okay, but we built a Cylon, so the speak that gets called won't be the pure virtual speak method from, our base class. It's going to be the speak method from the Cylon derived child class. So we set it up to point to the address of lifeform speak, and then all we have to do is we take our pointer to our object on the heap, use the arrow because it's on the heap. And this looks a little weird, but it's like multiple levels of indirection because number 6 is a pointer that points to our Cylon on the heap, and here is a pointer, a function pointer itself, a function pointer to a member function in the class. And so we're dereferencing and pointing to it. Here's our pointer. And when we do this, it points to the speak method. It's going to call by overriding in the pure virtual method and it being initialized to 0, it's going to call the speak method for Cylon. And the same thing here. We're taking our member class function pointer, having it point to the address of lifeform move. Well, move is pure virtual in the base class, the ADT. So it won't call the move method from lifeform. It's going to end up calling the move method from the child class, Cylon or human. In this case, Cylon, because number 6 points to a Cylon. And we just take our pointer and we take the arrow and oops, I didn't mean to drag. I'm using a little tiny mouse here that messes me up. All right, in this case we have our our member function pointer, and we dereference it to get at what it points to, the method that it points to. Whew, that was a mouthful. So if we run example 5, looking at the code there, so we build the project and see how it works. And again, this is just as an example to show how you would create a pointer to a member class function or a class member function, however you want to say that. I'm not sure the correct English on that or how to say that right, but notice that it says I am 6 and resurrecting. Alright, and again, that's because of the way our inheritance hierarchy is set up and the way that our pointers are set up. Because in our class hierarchy, we use the keyword virtual, which means that we have to override speak and move in our child classes, and we made it pure virtual. And a function is pure virtual when not only does it use the keyword virtual, but it's initialized to be 0 and it's constant. Example 6 involves arrays of pointers to class member methods. And last, we're going to take a look at example 6. Okay, so I'm going to comment out example 5. And it's our very last example here, our last function to call. And we'll scroll down to the code. And if we take a look at example 6, again, it's a little bit different, a little bit odd looking maybe. In this case, we have a pointer to a Cylon object, but it's initialized to null, to 0. Hasn't created anything on the heap yet, or been used to build anything. and we're going to use a type definition. A type definition is just a quick, user-defined or programmer-defined data type. And what we want to do is set up a Cylon member function pointer type definition data type here. Return type of void, and we're scripting into the Cylon method, and it's constant. And if we do that, then what we can do is we can take our Cylon member function pointer. I know that's a long name, but again, I'm trying to make it, what it is or what it does. I'm trying to use that as a name, the instance name. So our type definition, our data type here, Cylon member function pointer, we can then build an array of that data type, that type definition. So Cylon functions is an array of Cylon member function pointers. It's just going to hold 2 elements. And we're going to pass in the address of Cylon speak, and we're going to pass in the address of Cylon move. And remember, it just says I'm number 6 and resurrecting. Well, if we do that, we have an array. Arrays go with for loops, like peanut butter goes with jelly. So we're just going to loop through 2 times. Iterate, x will be the subscript value 0 and 1. We're going to build a new Cylon, and then when we build the new Cylon, we're going to take our Cylon functions here, our array, and the first element 0, we're going to call that, which this element here would be speak. It'll call the speak method. And then we're going to delete that Cylon. We're going to iterate through the second time. X now has a value of 1. Create a new Cylon, and then we're going to access this, the move method, and then clean up and call the destructor and destroy it. So again, if we rebuild the project and look at the code, let's see what that looks like. Okay, and basically the output is the same as example 5, although what we are doing is profoundly different.